These are the first 6 problems on the study guide for Test 3, Quarter 2 for Algebra B. So let's take a look at the first one. Here you're going to end up, the first 6 problems, you're going to end up using our 3 methods to solve systems. And so that's what I'm testing you on, all the different methods to solve systems, and then some word problems at the end. So let's take a look at the first 2. This is graphing. So we have to be able to graph lines using the slope-intercept form. So for the first one, y equals 1/2 x. Well, I don't see a y-intercept, so that means I can always put the number 0. So plus 0 is the number I'm going to put there, and that's where the y-intercept will end up being, is at 0. And so I'm going to go just right at the origin, put a dot there, and then use the slope. Well, the slope is always the number out in front of x. It's this number right there. So that means that I'm going to go in the y direction 1 space, x direction 2. So up 1, 2 to the right, up 1, 2 to the right, up 1, 2 to the right. I could also go the other direction. Remember, that would be a -1 over -2. So that would tell me to go down to the left, down to the left. And that gets me on that same line as well. Well, let's take a look at the next line. That one has a y-intercept of 3. So there's my y-intercept, and I'm going to go up 3 spaces, 1, 2, 3, on the graph. The slope is negative. Well, there's just a negative sign in front of x. What number can I put there? Hopefully you said -1. So that's my slope, -1 over 1. And that also is the same as +1 over -1. So I could go either down and then to the right, or I could go up to the left. And then if I go down to the right, though, I'm going to get the answer. See, right there is where they're going to end up crossing. And so that's my solution. Now, some people on the last test didn't write down the solution, so make sure you do. 2 spaces to the right, 1 space up. So the answer that you should box is 2, 1. And that would be it, the answer for the first one. Let's take a look at the next one. Now this one has 2 equations, but one's not in slope-intercept form, so we got to be careful. We'll get to that one second. So see how y is by itself. This is in slope-intercept form. Our y-intercept is -2, so I'm going down 2 spaces on the y-axis. Our slope is the number in front of x, only when y is by itself. So the slope is 1 to 1. And I can go up 1 and then to the right 1 a bunch of times to get on that line. But I should also go the other way, which in this case would be -1 over -1. So down and then to the left gets me on that same line. Well, let's take a look at the next equation. Here's where some students ended up not doing so well. You see, you've got to have y by itself. And this was actually a problem that we had on last week's test. And so here we have to subtract 2x from both sides first. You always need to isolate y. Once you've got y by itself, so I've subtracted 2x, I now have y equals, and then a -2x plus 1. So my slope is -2. My y-intercept is +1. Always isolate the variable first. So there's the y-intercept. So you're going up 1 space this time from the origin. And the slope is -2 to 1. -2 to 1. So that means down 2 over 1. And you get them to cross right away. Down 2 over 1. You do that a few times and you've got the line. So there's our point. It's 1 space to the right and then down 1 space, so -1. So 1, -1. So that's the key on that problem. One will be totally in slope-intercept form for both, but one, if it's not in slope-intercept form, you have to do some work to get it into slope-intercept form. Let's take a look at the next 2 problems. These are solving by substitution. So that's what I'm testing you on here. And they're great substitution problems because we have a variable by itself. Y is by itself. It doesn't matter whether it's y or x by itself, just one of them needs to be by itself. And what we're going to do there is put that x plus 3 in place of the y in the equation below. And then you just rewrite the equation, 2x plus y, but in place of y, you're writing x plus 3. And this all should equal 6 at the end. Well, you go ahead and do some work there. And I'm going to subtract the 3 from both sides. And I will also collect some terms here, the positive x, the 2x, and see what we get when we collect those numbers. Well, 3x is what you get from 2x and 1x when I add those together. And when I subtract the 3 from both sides, I get positive 3. And then from there, it's just a matter of doing some division. So I'm going to divide by 3 on both sides, and we'll have our answer. So in this case, we have x equaling 1. Well, we're not done yet. We still have to find y. So now we take that 1, we just put it in place of x in that top equation would be the easiest one. Let's rewrite that top equation. Y equals x, but in place of x, we're putting what x is. 1. 1 plus 3 is 4. So there it is. X is 1, y is 4. That's our ordered pair. Well, the next substitution problem is just a little bit more difficult because we've got a different coefficient in front of the variable that we're going to be substituting in for. We have y again. Now, your test might not have y by itself. It might be x. So whichever one's by itself is what you're going to put into the other's equation's variable. So I'm going to put y equals x plus 1. So x plus 1 goes in place of this y. Notice, since we've got that minus sign in front of that y term, I've got to put the expression in parentheses. So it's 2x minus y, but I'm putting x plus 1 in place of y. And this all equals negative 5. And so now I can distribute that minus sign, that negative 1, over that addition. So let's see what's left over. So I've got a 2x, a minus x, a minus 1 equals negative 5. So I just did the opposite, took the opposite of both of those terms. So now I'm ready to combine some like terms and isolate that variable. So I'll go ahead and add 1 to all sides here and collect these two terms. So 2x minus 1x gives me 1x. And then over on this side, negative 5 plus 1, remember opposite signs, so I subtract more negatives than positives. X is negative 4. So now we take that negative 4 and substitute back into probably that top equation right there. And for that x, let's rewrite what we've got. So we've got a y equals x. But in place of x, let's put our value of x, negative 4, plus the 1. So in this case, y equals negative 3. So there it is. Negative 4 comma negative 3 is the answer. Well, two more problems. These problems involve elimination. So you've got the 3 methods to solve on this test. And we've done graphing, substitution. Elimination is the one most people like. So hopefully we do well on these types. Here we're going to eliminate x's or y's. Now, in order to do this, you got to have everything in line. Equal signs, constants, y's, x's, they're all in line. Well, that's good. But we can't just add them together because we can't get those x's to cancel. Can't get the y's to cancel. So we're going to have to multiply one of the equations. Easiest one for me, at least, I think, is maybe just multiply this second equation by 2. And then we'll get a negative 2x to cancel out the positive 2x. So let's rewrite what we've got. When we do that multiplication, we've got negative 2x plus 6y equals negative 24. Make sure you multiply every number in that equation by 2. Just bring down this term here, and it's just going to be 2x plus y equals 3. So when we add that together, here we get these x's to cancel. And that's the whole idea behind elimination. It's to cancel out one of the unknowns. So we only have one to solve for. 7y equals negative 21. There's another mistake people will make. Doing this, they'll add instead of subtract. So you got to really be careful on the signs there. So from here, we're going to divide by 7. And when we do that, we've got now y equals -3. So from that point, we can take that -3 and put it in place of y in that equation above. So let's rewrite what we've got. 2x plus, and then put in the -3 in place of that y. So -3 equals 3. And so from there, we can just do some opposite operations to isolate that variable. So we'll just go ahead and add that 3 to all sides. Add that 3 here. And now we've got our 2x equals 6. Well, from that point, what we can do is do some division. So we can divide by 2. Divide by 2 on both sides, and then we've got x by itself. And so there it is. We've solved for it. X is 3. So you can write your answers in ordered pair. Remember, it goes in alphabetical order. 3, -3. And there is our solution. Well, one more problem. This one is another elimination problem, but a little bit tougher because we can't just multiply one equation to cancel out one of the unknowns. We have to multiply both. And so that's what we're going to do on this first one. I'm going to cancel out x's again, just like I did on the other one. So in order to get these so that they're the same number, I'm just going to multiply by the other's unknown, the other's coefficient. So 3. So 3 times 2 makes 6. So this makes 6x eventually. So I want this to be a -6x. Well, it's already negative, so let's just multiply it by 2. So every number on that bottom equation gets multiplied by 2. Every number on the top equation gets multiplied by 3. Let's rewrite what we've got now. So the top equation becomes a 6x, a plus 15y, and this all equals, now careful on that multiplication, it's 78. And then down below we've got a -6x minus 8y equals, and that makes a -50. So once you've done the modification of the equations, it's really fast. When we add these together, this should only be a two-step equation, or actually a one-step equation. Only one more step when we go ahead and add these. So these terms cancel out. The x's cancel out. That's why we call this elimination. And 7y equals, and this makes 28. You do some division, and you'll have your answer. So divide by 7 on both sides, and we've got y equals 4. Well, once we've got that, we've still got one extra step, and that's to substitute back in. So we're going to put this y back into one of the equations. I'm going to pick that top one before we modified it. So it's 2x plus 5 times by 4, and it equals 26. So the thing about elimination is it goes really fast for the first unknown, but the second unknown requires just a little bit more work. So here we have 2x plus 20 equals 26. And now we're on to our two-step equation that we can solve by just doing some opposite operations. So this is a 20 here, so I'm going to subtract it from both sides. And then from there, I'm left here with a 2x equals 6. So just one more step there, and that's to divide by 2, and you've got your value of x. So in this case, x equals 3. So we've got our answer. 3 is x, 4 is y, and we've got our solution. So there it is. Those are the different methods to solve systems. And again, there's 3 methods. We're going to do each of them, and you have to use the appropriate method to get full credit for the test. If you don't use the right method, you're not going to get full credit for that problem. So I want to see you using the 3 different methods for this. And then the last 3 problems will be word problems where we're going to set up or write systems to be able to solve for 2 unknowns. And the key is the number of unknowns you have is the number of equations you need. So we'll have 2 unknowns, so we need 2 equations. So part 2 will have the word problems.